In this video, we're going to solve for the velocity of the satellite, the acceleration of the satellite, and the period of the satellite. Our givens are that the mass is 617 kilograms, the Earth's mass is this number, and the distance from the surface of the Earth to the orbit of the satellite is this number, and this is the radius of the Earth. This number is on the reference table. Okay, so to solve for the velocity, we're going to use a couple of formulas. We're going to use F net equals ma. The F net in this circumstance would be the force of gravity, because that is what is keeping the satellite in orbit. So Fg equals ma. And the formula for Fg is the universal constant times mass 1 divided by the radius squared. And the formula for accelerations of objects in circular orbits is v squared over r. So when we plug that into there, we're going to get m v squared over r. Now looking at this equation, we can cancel out the mass of the satellite on both sides and the radius, leaving us with g times the mass of the Earth equals velocity squared divided by r. So to solve for velocity, we'd square. We'll take the square root of this, and we'll get a number. When plugging in for r, you have to use the radius of the Earth plus the distance from the surface of the Earth to the satellite. And when you do that, you're going to get the velocity of 4.93 times 10 to the third meters per second. Okay, for part 2, for finding the acceleration of the satellite, we're going to use this formula again for v squared over r equals the acceleration. From the previous part, we found that v squared equals this. So we're just going to plug that in over here. End up looking like keep change flip, guys. That's an R. That is an R. I'm taking R squared. And then we're going to plug in the values and find the acceleration to be the acceleration is going to equal 1.49 meters per second squared. When we're finding the period, we're going to plug it into the 2 pi r over velocity, and when you do that, you get this number. But to convert it to scientific notation, you'd put a decimal point there, 1, 2, 3, 4, and you round it if you want. So 2.1 times 10 to the 4th seconds is the period. These are the values we solved for.